All right, hi guys, it's Mr. C with your Saxon Math. Today we're doing lesson 87 where we're estimating square roots. Now this is a lesson that is good practice because we're estimating. I can't think of a lot of times in my life where I needed to estimate square roots. That just didn't become something that I needed to calculate all the time. However, the process of estimating square roots is really good practice for other kinds of estimating that we do in the real life, and so this is a good lesson to practice that. So we're going to look at square roots with a perfect square greater than 100 to find perfect squares, and then we're going to also find square roots that don't have exact numbers, that are going to be decimals, and so we're going to practice doing that as well. All right, so we've practiced finding square roots from 1 to 100. If you can think back like this, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, because it's just 4 times 4 is 16, 5 times 5 is 25. We've done that up to 10. 10 times 10 is 100, and actually we know our 11 times tables and 12 times tables too, so we've really gone up to 144. In this lesson, we're looking at perfect squares greater than 100, and we'll also use guess and check to find other squares, okay? So here we're looking at 400. Now, we can think about this logically, right? If the square root of 100 is 10, well, then we know that this is going to be greater than 10. Now, if we did, like, maybe the square root of, 100 squared would be 10,000, right? So we know that's way too high. If we start dropping that down and trying different things, say we try 30 times 30, then we're going to have our 2 zeros there and a 9, so we have 900. So the square root of 900 is 30, so obviously that's much higher. We can look in the middle then, and honestly this one makes sense, because if we think 1 times 1 is 1, 2 times 2 is 4, and we're looking for 400, well then we should just try 20 times 20. So we've got 2 zeros here, so we're just going to add our 2 zeros, and then 2 times 2 is 4, and we get 400. So it checks out, it's 400. You see how I just did guess and check though? And that's the important thing here, is when we're trying to figure these perfect squares, a lot of it is just guess and check. Now, there are strategies that you can use to get closer in your guessing and your checking, but a lot of this just comes with practice, and that's why we're doing it. All right, so 400 equals 20. Let's try this one, square root of 625. Now, we already know that 20 times 20 is 400, and now we're looking for something that will equal 625, so it's going to be higher than 20. We also already calculated that 30 times 30 is 900, and that's higher, so we know it's going to be somewhere between 20 and 30, right? Now, if 20 is 400 and 30 is 900, right in the middle of that is going to be close to 625. So let's start with 25, right? So if we do 25 times 25, 5 times 5 is 25. Drop our 0, 2 times 5 is 10, and a 5. And look at that, 5, 2, 6. It is 625. So we got lucky on this one just by guessing, because it was somewhere in the middle of 20 and 30. And because we've practiced, we kind of had a ballpark for where to guess. Let's see what they did. He said 625 is greater than 400. Oh, and they also did 30, so they used the same reasoning I used. So that's great. All right, let's try another one. Between which two consecutive whole numbers is the square root of 20? Now, this is easy because we can just start, this is a low number, so we can just think, all right, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. Are we getting close to 20 yet? Nope. 4 times 4 is 16. Now we're getting closer. 5 times 5 is 25. Well, 25 is too high. So we know now it's got to be 25 is above it and 16 is below it. What are the numbers that go into that? 4 and 5, right? So the square root of 20 is somewhere between 4 and 5. Now, do they want us to do anything else with that? So I did it in my head and talked to you about it, but they actually wrote out the squares. But then, yeah, see, they found the same thing, 16, 20, 25. So it's going to be somewhere between 4 and 5. Now, using this reasoning from example 3, we know that it's somewhere between 4 and 5. It's not going to be a whole number. So we could practice and just do 4 times 4.5 times 4.5, and that's going to give us 20.25. So that's really close to the square root of 20. So it's not exactly, but since it's higher, then we could go, well, let's try 4.4. 4.4 times 4.4 is 19.36. Which one of those is closer to 20? It's this one. So we know it's going to be higher than 4.45. It'd probably be 4.46 or 4.47, somewhere in there. But we're estimating here. So because 4.5 is the closest, if we just want to round there, then we could say 4.5 is approximately the same as the square root of 20. Now, because it's a decimal that could keep going on, we know it's going to just keep going on. If we do 4.46 something, that's called an irrational number. The way I remember that is pi. Remember 3.14, and then there's a bunch of numbers after that. That's an irrational number. Thinking about eating pie in the middle of math, that's irrational, right? And so that's the way I remember what irrational numbers are. With an irrational number, we're just going to round or estimate, okay? So here they're going to say it's approximately 4.5. All right, and that's it. So we're just going to practice in this lesson, finding perfect squares and then guessing on irrational numbers what the closest number is to find that square or square root.